Hi, this is Mark from Tabor Electronics. We're here at IMS 2024 in Washington, D.C. I'd like to talk about a project that we did with Rutgers University. We've created a wireless test bed, and it's based on our arbitrary waveform transceivers, some up converters from TMYTEK, and some horn antennas, and we've got here a whole 40 gigahertz microwave link. You can see the signal amplitude changing as I put my hand in front of it. At the heart of the system is the transceiver. So we're generating an IF at 1 gigahertz and receiving at 1 gigahertz. And then we use the TMYTEKs to get up to 30 gigs or 40 gigs, all different frequencies. And Ethan's going to tell us about those up converters and down converters now. Thanks, Ethan.
Yeah, thanks, Mark. Hi, Ethan Lin, TMYTEK. We are at IMS 2024. Thanks, Mark, for the introduction of the architecture. Our device, we offer up-down converters. We call it UD-Box 5G. Frequency ranges from 24 to 44 gigahertz. So that device definitely offers a good signal-to-noise ratio performance and extend the frequency range of the device from Tabor. And now here is the new model from my hand. That's that we build a new up-down converter for FR3. So that one we call it UDB 630. So the frequency range spans from 6 to 30 gigahertz. Definitely a great device for FR3. Thanks, Mark.
Yeah, so we're very excited. The first project that Rutgers University are going to do is to test some encoding for FR3, the new 5G advanced system. And they're going to go on to do a lot more research, and we're glad to be enabling wireless research for the rest of the world. Thank you, everybody.
Thank you.